The next topic is the peripheral register header files. After completing this module, you will understand the usage of the header files. The remaining lab exercises in this workshop will make use of these header files. In the traditional approach to C coding, we used a #define to assign the address of the register and referenced it with a pointer. The first line of code on this slide, we are writing to the entire register with a 16-bit value. The second line, we are ORing a bit field. The advantages: simple, fast, and easy to type. The variable names can exactly match the register names, so it's easy to remember. Disadvantages: requires individual masks to be generated to manipulate individual bits. It cannot easily display bit fields in the debugger window, and it will generate less efficient code in many cases. The structure approach to C coding uses the peripheral register header files. First, a peripheral is specified, followed by a control register. Then you can modify the complete register or selected bits. This is almost self-commented code. The first line of code on this slide, we are writing to the entire register. The second line of code, we are modifying a bit field. Advantages: easy to manipulate individual bits. It works great with our tools and will generate the most efficient code. Disadvantages: can be difficult to remember the structure names and more to type. However, the editor autocomplete feature of Code Composer Studio will eliminate these disadvantages. With the traditional approach to coding using #define, we can only view the complete register values. As an example, notice the ADC control register 1 has a hex value of 40E4. We would need to refer to the reference guide to know the settings of the individual bit fields. With the structure approach, we can add the peripheral to a watch window, allowing us to view as well as modify individual bit fields in a register. No need for a reference guide to identify the bit fields. The header files define all of the peripheral structures, all of the register names, all of the bit field names, and all of the register addresses. The most common naming conventions used are peripheral name.registername.all, which will access the full 16 or 32-bit register, and peripheral name.registername.bit.fieldname, which will access the specified bit fields of a register. Here, I will show you how the editor autocomplete feature works. First, I type ADC regs. Then, when I type a dot, a window opens up allowing me to select a control register. We will select ADC control register 1. Then, when I hit the dot, a window opens up allowing me to select all or bit. We will select bit. Then, when I hit the dot, a window opens up allowing me to select a bit field. We will select reset. And now the structure is completed. The F2806X header file package contains everything needed to use the structure approach. It defines all the peripheral register bits and register addresses. The header file package includes the header files, linker command files, GEL files for CCS, code examples, and documentation. The header file package is available from Control Suite. Next, we will discuss the steps needed to use the header files with your project. The .h files contain the bit field structure definitions for each peripheral register. The header file package contains a .h file for each peripheral in the device. The F2806X_device.h file is the main include file. It will include all of the other .h files. There are 3 steps needed to use the header files. The first step is to include this file directly or indirectly in each source file. The global variable definition file declares a global instantiation of the structure for each peripheral. Each structure is placed in its own section using the data section pragma to allow linking to the correct memory. The second step for using the header files is to add f2806x underscore global variable defs.c to your project. The header file package has two linker command file versions, one for non-BIOS projects and one for BIOS projects. This linker command file is used to link each structure to the address of the peripheral using the structure's named section. The third and final step for using the header files is to add the appropriate linker command file to your project. The peripheral register header file package includes example projects for each peripheral. This can be very helpful to getting you started. In summary, the peripheral register header files allow for easier code development, they are easy to use, generates the most efficient code, works great with Code Composer Studio, and TI has already done the work for you. Just make sure to use the correct header file package for your device.